Hi everyone, in this class we'll see how to derive the characteristic table of JK flip-flop using NAND circuit guys. Okay, fine. In the earlier classes we have seen how to draw synchronous JK flip-flops as well as asynchronous JK flip-flops. Okay, fine. So guys, characteristic table means which is going to clearly define for what kind of inputs, what are its next states it's going to clearly define. That is what we can say that it is a characteristic table, right? So here if you are able to observe uh, J and K are the inputs, Q1 is the present state and Q1 plus 1 is the next state. Okay, fine. So now we have to define for what kind of inputs how this JK flop is working, right? So basically guys, JK flop is same as like SR flop only, but the difference is when you are going to give the input as 1 1 for SR, it is going to be undefined state, whereas coming to JK flop, it is going to be in the complemented state, right? So let's see how it is working and how it is behaving, right? So guys, basically if you are going to start with J and K values as 0 0, and when you are going to have J value as 0, K value as 0, can you able to solve this circuit? No, it couldn't possible because this A NAND gate requires one more input. That input is coming from Qn bar, right? So you have to know the value of Qn bar, but this Qn bar is depend on this D NAND gate, right? So this D NAND gate is depend on Qn, right? So like that, it is entirely dependent on one among each other, right? So what we can do now, we'll simply assume the Qn as 0. Once you assume the Qn as 0, what might be the Q1 bar? As per our explanation, it should be 1. It should be 1, right? Yes. Once Q1 bar is 1, this 1 will be reached to A NAND gate input. As Qn is 0, it will be reached to B NAND gate input. Okay. Now we can able to solve it, right? So try to solve. At the A input NAND gate, we have A0, and what about this clock? Assume that the clock is always high. So it depends on the latch, or it depends on flip flop. We can able to define the type of clock we are passing here, right? So here it is 101. So when it is 101, how the NAND gate is going to behave? For example, if I take 00, 01, 10, 11, and for the AND gate, you are going to get 0, 0, 0, 1. For the NAND gate, you are going to get 111, 0. Am I right? Yes, meaning that when all are ones, then only your output is 0 for the NAND gate, right? So as here, there is at least 1 0, I can say that my output is going to be 1. Right? Similarly, here also 100 means your output is going to be 1. When it is 1, can we able to get the another input of D NAND gate? Yes. So the D NAND gate input is, here it is 0. Here it is 0, right? What is 10 over the NAND gate? 10 over the NAND gate is 1, right? So we got as per our expectation. Now this 1 will be reached to here. What is 1 and 1? 1 and 1 NAND gate is 0. Yes, good. We got the 0. Means the next state we got as 0. So meaning that this is Qn actually. For the next iteration we got also 0. Now try to send this 0 to here, right? So meaning that you need to iterate the circuit. Meaning that this 0 will be sent to again here. Let's see for next iteration whether it is working or not. 0 will be coming here. This 1 will be coming here. And you know it is as like as earlier one. So you are going to get again same 0 for the next state and 1 for the next state, right? So if you are able to observe it, so your Q1 plus 1 will be 0. Q1 plus 1 will be 0, right? Next possibility is J and K are zeros and q1 might be 1. q1 might be 1, right? When q1 might be 1, you have to take the q1 value as 1, and what about the q1 bar value? We are assuming it as 0. We are assuming it as q1 bar is 0, that will be sent it to the A input NAND gate. As q1 is 0, q1 is 1, that will be sent it to the B input NAND gate. Now try to resolve it. 0, 0, 1. 0, 0, 1 is 1. What is 1, 0, 1? Again 1. Again 1, right? At the D input AND gate, you are going to get 1 as one input. Another input is q1. q1 is 1. What is 1 and 1 AND with 1? 1 AND with 1 is 0. Means we are getting as per our expectation. Now this 1 will be sent it to here. What is 1 and 1? You are going to get 0. You are going to get 0. Right? See, here it should be, sorry. We got as per our expectation. Now this will be sent it to here 0. What is 1 AND with 0? 1 AND with 0 is 1. It is working as per our expectation, meaning that q1 is 1, q1 plus 1 is also 1. Now what will happen? This 1 will be sent it to here, this 0 will be sent it to here, and it is going to do the same process. As earlier also we have seen the input as 0 and 1, it is going to work as it is, right? So you are going to get here also q1 plus 1 is 1, meaning that if you are able to observe, for the inputs of jk 0, 0, you are going to get q1 plus 1 as 0, 1 only, meaning that which is equal to q1. I can say that this state as latch state. If you are able to observe, in SR flip also, when S and R values are 0, 0, whatever the values that are there in the q1, the same values are going to be produced in the q1 plus 1, meaning that it is also a kind of latch state. Means when SR are 0, 0, q1 plus 1 is latch state. The same thing here also working, right? Let's see what are the another possible values, right? The another possible values are j and k are 0, 1. q1 might be 0 one time, or q1 might be 1. Let's analyze it. So let me give the input of j as 0, input of k as 1, right? And I am assuming that q1 is 0 right now. When q1 is 0, q1 bar is going to be 1, right? When q1 is 0, that will be updated the B input NAND gate. When q1 bar is 1, that will be updated the A input NAND gate. Now try to solve it. 1, 0, 1. 1, 0, 1 is 1 NAND gate. 1, 1, 0. At the NAND gate, you are going to get 1 as output, right? Now at the D input NAND gate, 1 is the one input, other one is 0, 0. What is 1 and 0 over the NAND gate? You are going to get 1. It is working as per our expectation. Now this 1 will be sent it to here. What is 1 with 1 over the NAND gate? 0. NAND gate is 0. So meaning that q1 is 0, q1 is 0, q1 plus 1 is also 0. Now try to resolve it. Now this 0 will be sent it to again back to B input NAND gate. Again this 1 will be sent it to A input NAND gate. Again we'll do the same process. Even, right, what will happen earlier also we have the values here as 1 and 0. So your circuit is going to get again 0 and 1 as a next state. So meaning that here you are going to get 0. Here you are going to get 0, right? Similarly, what might be the values of when q1 value is 1? When q1 value is 1, q1 bar is going to be 0, right? When q1 is 1, that will be updated at the B input NAND gate. When q1 bar is 0, that will be updated at the A input NAND gate. Now try to think 0, 0, 1. 0, 0, 1 means you are going to get again 1. At the B input NAND gate, 1, 1, 1 means here we are going to get 0, guys, because all are 1s. When all are 1s, your NAND gate is going to produce 0. Now analyze it. 0 is one input and another input is 1. 1. So that is given. 0 and 1 over the NAND gate, you are going to get 1. You are going to get 1, guys. See, this is not getting as per our expectation. As per, let's see for the coming address whether it is working fine or not, right? 1, that 1 will be sent here. 1 with 1 over the NAND gate, you are going to get 0. You are going to get 0. Means here Q1 is 1, Q1 plus 1 is 0. Q1 plus 1 is 0. Now try to analyze. This 0 will be send it to back to here. This 1 will be send it to here. Right? We are going for further iteration whether it is working fine or not, right? So we got here 1. So 1 0 1, you are going to get 1 1 1 0. We are going to get here 1 now. What is 1 and what is this value? This value is 0 now. 1 NAND with 0, you are going to get 1. You are going to get 1. Good. This 1 will be sent to here. 1 NAND with 1 is 0. 1 NAND with 0. Meaning that here you got 0, here you got 1 guys. 1 guys. So now this same input 0 will be sent to here. This 1 will be sent to the A input NAND gate, right? So earlier case is what? The same values 1 and 0. You are going to get always zeros. Here you are going to get always ones. Means that when you are going to have the input, the Q1 might be 1, you are going to get always 0. Always 0. This is what we can say that it is reset state. So whereas in SR also, when you are going to have SR as 0 1, the Q1 plus 1 will be reset state. Always it is going to produce 0 as the value. Okay, fine. So what will be the next possible values? 1 0 are the next possible values, and Q1 can be 0 or 1. Right? Let's analyze what might be the values for 0 and 1 when the inputs are J, K as 1 0. Let's see, when J and K are 1 0 and Q1 is 0, what might be happen, right? So J value is here 1, K value is 0, right? Q1 I am assuming that it is 0. When assuming it as 0, Q1 bar should be 1, right? So when Q1 is 0, the B input NAND gate is 0, Q1 bar is 1, A input NAND gate is 1. NAND gate is 1, right? Now try to solve it. 1 1 1, you are going to get output as 0. 1 0 0, you are going to get output as 1, right? Now at the D input NAND gate, you got the one value as 1. What about another value? That is 0. 1 0 NAND gate over is 1. It is working as per our expectation. Now this 1 will be sent it to here. What is 0 1? 0 1 is 1. Means next state you got as 1. So means Q1 is 0. Q1 plus 1 is 1. Right? Let's reiterate whether it is working fine or not. Right? So this 1 will be sent it to here. Send it to here. This 1 will be sent it to A input NAND gate. Right? Now 1 1 1. When it is all ones, you are going to get here 0. Good. Now here 1 0 1, you are going to get here 1. Now here you are going to get the value. What is 1 and 1? 1 NAND with 1 is 0. Good. NAND with 1 is 0. Now this 0 will be sent it to here. 0 NAND with 0, you are going to get 1. Which means that if you are able to clearly observe, so this is 1, this is 0. If you are going to reiterate it, you are going to get next here also 0 and so on. Meaning that when Q1 is 0, Q1 plus 1 is going to be 1. Q1 plus 1 is going to be 1. Okay, fine. Similarly, if we are going to assume it as 1, we are going to assume it as 1. Here Q1 bar should be 0 as per our expectation. As like Q1 is 1, Q1 bar should be 0. Now when the Q1 bar is 0, here at the A input NAND gate you are going to get 0. At the B input NAND gate Q1 is 1, so it will be updated as 1. Now think 0 1 1. 0 1 1 means you are going to get 1 at the output of NAND gate. 1 0 1, you are going to get output as 1 at the output of NAND gate. Now this 1 will be the input of D input NAND gate, and What might be the another input? Your other input is 1. This 1 will be sent it to here. What is 1 with NAND gate? 0. Good, right? So it is working as per our expression. Now the 0 will be sent it to here. What is 1 with 0 NAND gate? 1. 1, right? Means Q1 is 1, Q1 plus 1 is 1. Now this 1 will be sent it to again at the B input NAND gate, right? 1 0 1. 1 0 1 is okay, fine. First I will update here also. Q1 bar is 0, that will be updated here. Now try to solve it, right? 0 1 1. See guys, if I are able to observe, these inputs are not changed. That's why we can get the same values only. So the next state is you are going to get as 1, which means that this is set state, means which is like as a SR flip flop only. When 1 0 are the SR inputs, you are going to get set state, right? Similarly, the next call values are 1 1 for the J and K, means J value is 1, K value is 1, and Q1 might be 1 time 0, 1 time will be 1. Now let us check for J and K as 1 1 and Q1 0, what will happen to the circuit? Right? Q1 equal to 0, J is 1, K is 1, right? As Q1 is 0, Q1 bar will be 1, right? So when Q1 bar will be 1, at the A input NAND gate it will be 1, at the B input NAND gate it is 0 as Q1 is 0, right? Now solve at the A input NAND gate. A input NAND gate contains all ones, so output will be 0. B input NAND gate 1 1 0, output will be 1, right? At the D input NAND gate you got one input as 1, the other input is 0 as Q1 is 0, right? 1 0 NAND gate is 1. Yes, done. It is working as per our expectation. Now this one will be sent to here. 0 with 1 NAND gate is 1, which means that Q1 is 0, Q1 plus 1 is 1. When Q1 plus 1 is 1, it should be 0. Q1 plus 1 bar should be 0, right? Now try to iterate. So Q1 is 1, that will be updated in the B input NAND gate. Q1 plus 1 bar will be updated at the A input NAND gate. What is 0 1 1? 0 1 1 is 1 at the A NAND gate, and at the B NAND gate you are going to get 0 as the output, as all are 1s, right? Now 0 with the another input is 1. 0 with 1 is 1. 0 with 1 is 1, right? This 1 will be sent it to here. Will be sent it to here. So this is 1, guys. This is 1, right? This 1 will be sent it to here. What is 1 NAND with 1? 1 NAND with 1 is 0. 1 is 0, right? When 1 NAND with 1 is 0, this is now Q1 plus 1, right? So assume that this is earlier set, present set as Q1. This will be now Q1 plus 1. When this is Q1 plus 1, you can make it as like this will be Q1 plus 1 bar, that is 1, right? Now I iterate once again. So Q1 is 0, will be sent it to here. Q1 plus 1 bar is 1, right? As all ones, you are going to get the 0 as output. As 1 1 0, you are going to get the output as 1, guys, right? As at least 1 0 is there, so you get 1, right? Now 1 with 0. 1 with 0 is 1. 1 with 0 is 1. Okay. This 1 will be sent to here. What is 0 with 1? 0 with 1 is 1. 0 with 1 is 1, right? Now this 1 will be sent to here, right? And here as it is 1, it should be 0. This 0 will be sent to here. Sent to here, right? Now if you are able to observe, this process is continuously repeating. This process is continuously repeating, and so on. And so on. But the thing is, when your input is 0, Q1 input is 0, Q1 plus 1 will be 1. Q1 plus 1 will be 1. Guys, in the next class, I will try to explain what will happen to this particular scenario, right? Yes. So Q1 plus 1 will be 1. Now similarly, if you are going to take the Q1 value as 1, Q1 value as 1, let me write with red color. Q1 value as 1, Qn bar will be 0. If you are going to be process it, you are going to get 1 0, 1 0, 1 0, 1 0 and so on. Means when Qn is 1, Qn plus 1 will be 0. Qn plus 1 will be 0. Right? Means it will be in the complement state. Complement state, right? So this is the characteristic diagram, characteristic table for the respective JK flip-flop using NAND circuit, right? Yes. So whereas coming to, if you take SR flip-flop, when 1 1 is there, you are going to be undefined state. So this is the advantage of this is the drawback of SR flip-flop and the advantage of JK flip-flop, right? So in JK flip-flop, we are going to get utilizable state, right? That is what complement state. Right? Similarly, can we draw the function table for this? Yes, right? So function table means we are going to separate simply your output in terms of some of the inputs, right? So here J and K are the inputs, output is Q1 plus 1. So when J and K are 0 0 0 1 1 0 1 1 1 1, what might be the Q1 plus 1? Q1 plus 1, can we write it in terms of Q1? Yes. When J and K are 0 0, Q1 plus 1 is latch rate, which means that as like as Q1, right? So this is 0 1, this is also 0 1. So same, I can write simply as like as Q1. Similarly, when J and K are 0 1s and Qn is 0 1, but irrespective of this Qn, you are always going to get 0. So I can write as Qn plus 1 as 0. Similarly, when Jk are 1 0, Qn is 0 1, you are going to get always the state as 1, set state. So I can write as Qn plus 1 as 1. Similarly, when J and K are 1 1, you are going to get two cases, and Qn will be 0 1. If you are able to observe, it is getting the 1 0, right? Means that when Qn is 0, Qn plus 1 is 1. When Qn is 1, Qn plus 1 is 0. Which means that I can write as Qn bar. So this is the respective function table for the JK flip-flop. Okay, fine. I hope you understood clearly.